Let's spend a bit more time on the magnetic susceptibility chi. If we take a material like a soft iron core, we find that the dipole moments align with the solenoid magnetic field B0. So we start out with a solenoid field of B0, and after inserting the soft iron core, we get an additional magnetic field in the same direction as B0. So the total magnetic field increases. In this case, chi is greater than 0. The soft iron core is also called as a paramagnetic material. Now, if we replace the material inside with copper, we find that the dipole moments align in the direction opposite to the magnetic field of the solenoid. So we start out with a solenoid of field B0, and after inserting the piece of copper, we get an additional magnetic field, but in the opposite direction to B0. So the total magnetic field decreases. In this case, chi is negative. Copper is called as a diamagnetic material, and we will see that more in details in the lessons to come. Before we get into the details of paramagnetism and diamagnetism, let's go through another important concept. So far, we have dealt with a dipole moment due to an electron rotating in an orbit, but also the electron spins around itself, just like when the Earth revolves around the Sun, but also spins around its own axis. So there is a second dipole moment that we have to consider due to the electron spinning about its own axis. Let's say that the electron rotates clockwise in an orbit around the nucleus. So its magnetic moment, ml, due to its rotation around the nucleus, points upwards. Let's also say that during the rotation, the electron also spins around its own axis in a clockwise manner. Then, due to that spin, there will be a second magnetic moment, ms, which in this case would also point upwards. Now the net magnetic moment pointing upwards would be the vector sum of ml and ms. Now we take a case where the electron rotates clockwise in an orbit around the nucleus, but its spin around its own axis is anticlockwise. Its magnetic moment, ml, due to its rotation around the nucleus, points upwards, but its magnetic moment, ms, due to its spin, will in this case point downwards. Now the net magnetic moment pointing upwards would be the vector sum ml minus ms in the upward direction. Now if ms happens to be greater than ml, then the net magnetic moment would point downwards. In the further lessons, when we talk about magnetic moments, you will have to think in terms of the net magnetic moment, considering both the orbital and spin magnetic moments.